Well, hello everyone. It's been a while since I last uploaded a video, but been very busy and I finally found the time to make another video. So, recently just put together this project after a project that I first made a long time ago. Now, long time ago, my father and I built a refrigeration system designed to cool a computer, and I posted the results of that on YouTube, and that was my first video. It wasn't a very good one, but today I want to show you that project rebuilt and give you a little more in-depth explanation as to why I'm doing this, and show you it in action with a little bit better explanation, and show you what the computer does when this crazy contraption runs. Okay, before I get talking on the explanation of it all, I wanted to show you a few basic parts. This is the evaporator enclosure. Inside is the refrigerant evaporator. That's the part that cools, and it's sealed up. And these are two of the ventilation fans that circulate the air throughout the computer case. And here is the compressor, and over here is the condenser and the condenser fan. Yep, there it is. And that transformer there is just to run the fans. They're 240 volt fans, and normally I have this plugged into 120 volts because it's 120 volt compressor, so I guess I'd have to have a transformer either way. Could do it 240, but then I'd have to have a transformer for the compressor. So, as I said, a while ago, my father and I had just had this crazy idea to cool a computer with refrigeration. And if you've watched any of my videos before, when I talk about electronics, you usually hear me talk about cooling electronics and how important that is. And it really does change the dynamic electrical characteristics of any silicon semiconductor, the temperature that is. And usually they prefer to be cooler rather than warmer. Now usually when you hear of computers and overclocking and cooling, you think of liquid cooling, but as I've said before in my videos, there are a lot of downfalls and disadvantages to liquid cooling, especially when it comes to pumps. They can be noisy, not that a refrigeration system isn't, but the pumps are noisy, they can get clogged with debris, the bearings can go out, and you can get a lot of nasty bacteria and things growing in a liquid cooling system. And then what's worse, if it leaks, it's not fun, and it's not particularly useful. It's good when it's working, but it doesn't let you go to sub-ambient temperatures. It doesn't let you go below ambient. So you always have to have a higher temperature than your ambient temperature in order to release heat anyway. So, just in my opinion, it wasn't all that really worth it. So, I wanted to try something different. So, I made this. And I won't say that it's strictly limited to computers. And I want to have flanges here with hoses so I can hook it to other things like motor controllers and fun things besides computers. But the other real advantage of this, besides that you don't have to deal with liquid and you don't have to worry about liquid getting on the electronic components, is that all of the condensation will be on the outside and not on the inside of the computer. Because when you think of refrigeration, usually you think of insulating a CPU against condensation, because the CPU is going to be colder than the air. But with this system, all the condensation stays on the outside. It's completely dry on the inside. It's just like a refrigerator would be, and it drips out condensation through a condensate drain, which then the condensate evaporates. So, that's enough talking. Let's turn it on. Okay, here's a computer just running without the refrigeration system. And here's the current temperatures and the CPU specification, clock speed, and I believe this system temperature is inaccurate. I believe the CPU temperature is mostly accurate and the hard drive temperature should be mostly accurate. They all look about the same now, but once I start it up, the system temperature sensor is really going to go wacky. I don't really believe that to be accurate. So with that in mind, I'll start it up and see what it can do. Alright, so the system's been running now for about 5 minutes. You can see the CPU temperature is falling nicely. Don't pay any attention to the system temperature. I believe that's wrong. I believe the CPU is correct. Switch it to Celsius for you. Let's let it run a little bit longer. See what else it can do. So while we're waiting for that to cool down, let's take a look at what this condensing unit's up to. So you can see the pressures there. This is R134A that the system is running. It's not too terribly loud. It is loud, but it's not ridiculously loud. I don't know how it sounds on camera. It's not too bad in real life. You see a capillary tube going into the evaporator. That's the suction line coming out of the evaporator to the compressor. And the compressor is not hot at all. So you can see it from the other side. I've only got the low side hooked up through the process tube there. Tried to make it as simple as possible with as few potential leak points as possible, so I just had the process tube brazed on there. Brazing was done by my father because he's pretty good at it and he likes to do it. So argon was run through the system. Just in case you're curious, there's no copper oxide flakes running around in there. It's all been done the right way, or as right as we could get it. So you can see it holds pretty steady. There's not much excitement there. Okay, had it running for a while. As you can see, the CPU temperature has dropped down to 23 Fahrenheit. Now I have had it lower than this. Oh, it's gone down 22, just as I was speaking. Have had it lower than this, as I was saying. Had it down to 18 Fahrenheit. But for now, let's just go ahead and start putting a load on it and see what it does when the CPU is being utilized to its fullest. Alright, I have a couple things running in the background. And it should get the CPU at least close to 100% use. Don't have any real proper benchmarking tools for this, but as you can see, it seems to keep it at a fairly reasonable temperature. Change to Celsius. And again, don't believe that system. That's totally wrong. The CPU and hard drive, those are accurate. So, it's not completely finished yet. It's not perfect yet. But, with a little work, I think I can probably get that temperature down a little bit more, but still not too bad. Okay, with 100% CPU usage, the temperature is still a lot cooler than what a CPU would normally be running, even with liquid cooling. And again, there's no condensation on the CPU or motherboard. The only condensation that occurs is on the outside. So let's take a look and see if there's any condensation. Well, as you can see, there is quite a bit of condensation on the outside of the case. But I'm sure that's nothing a little insulation couldn't fix. Yeah, it's getting quite bad actually. But I'm sure it could be taken care of. And again, that's on the outside, and most of that's going to end up down there, and the condenser fan's going to dry all of that out once the unit is turned off. Alright, so I've just turned it off and it's thawing out now. So, as you can see, we've got quite a bit of condensation going on. But overall it works. I think there's room for improvement on the condensation. Definitely have to get some sort of condensation pan for that. And I want to get frame put under here. I've got a frame, I just need to cut it and get that bolted on. And definitely insulate the case a little bit. But I think the theory is definitely there, and I think it does work. Just some practical concerns with it. But as you can see, definitely much colder than liquid cooling, and any condensation that does occur always occurs on the outside of the case, not the inside of the case. So it's actually drying out the inside of the case. And, well, I think that's about it for this one, guys. You can always comment or message if you have any questions. If you'd like to see something, go ahead, let me know, and I'll try to get that done for you. And thanks for watching.